Welcome. Thank you. I went out to a refinery last week and I thought about, do we want to just jump into how to read a risk engineering report, or should you learn a little bit about what the facilities are first? And I thought about, let's talk about what risk engineering is in the energy sector for property. And what we want to do is look at the things that go wrong, right? We're going to try and distinguish, because there's so many different worlds of risk management, that we want to focus on the bad stuff, okay, that happens to our property. So by the end of this section, we're going to understand what property risks specific to the energy sector are. Yay. Way to go. All right. So why do we want to narrow it down? Well, within risk management and risk engineering, we can find ourselves going down the property path, personal injury path, or third-party liability path. Not many brokers or engineers understand third-party liability, but it's another sector out there. So today we're going to talk about property. And what we want to make sure that everybody understands, the key concepts is that the property risks are things that can happen to our stuff, right? Fire, flood, wind, just the things that can go wrong. And the energy sector, it's power generation, which includes nuclear power, renewables, fossils, all sources of storage. So power generation's broad all by itself. Then we have oil and gas, which includes chemical manufacturing, exploration and production, processing of the gas, the refining, the transmission and distribution, finally, of getting those products to market. So in the energy sector, we've got T&D, transmission lines, and transmission pipelines. What are the assets that we have out there? Besides pipelines, we've got plants, we've got substations, warehouses, office buildings, just a variety of physical structures that we need to be concerned with and manage. And then we have the concept of accidents versus wear and tear. Now, in risk management, we need to be aware of all the risks, but we also have to realize that some of the risks can be transferred to an insurance company through a contract, an insurance policy. Others can't. And generally, it's the wear and tear type things that we know and we already budget into our maintenance of the facility that don't get covered for insurance. It's the sudden accidental events that get covered by insurance. Let's just leave it there for key concepts. What drives our risk in the energy sector? Lots of energy. We're moving lots of large quantities of fuel. We have large machines that are moving very quickly and they have low tolerances. So we're always trying to push efficiency. One of the ways you drive lower environmental impact is to be more efficient with your fuel. The less fuel you burn to get the same output, the less pollution you create. All right, what are the assets within power? Well, within power, we have boilers. We can have $100 million explosions in a boiler. There have been several large boiler events in the industry. All the emission systems bring along their own set of risks. All the SCRs and NOx and ammonia. You have to be aware of the types of chemical processing that go on in the power gen space. Turbines, we have gas turbines, steam turbines, wind turbines. I make a joke about solar turbines. They're really gas turbines, but there's a manufacturer named Solar. So these are large rotating pieces of equipment with very fine tolerances, and they run all the time. So they're either worn out or they cycle all the time, and then they wear out from cycling. So the turbines are a huge asset, can lead to large losses. Typically, bearing wipes in these things are in the $5 million range. If you start throwing blades in a gas turbine, you can be looking at $20–25 million to repair gas turbines. Generators, these are very heavy, very large, and depending on how they're cooled, they can add hazards. You can cool them with air, hydrogen, or water, and they all bring along their own set of risks. Without a generator, a power plant's pretty much useless. Same with their transformers. The generator step-up transformers, just one more in that bottleneck that are very likely to cause a plant-wide shutdown. Transformers may not be your largest loss in the plant, property damage-wise, but they can shut you down for a very long time. 12 to 18 months, and even now maybe up to 24, depending on the configuration of your transformers. Rotating equipment. We have a lot of rotating equipment besides turbines and generators. We have pumps, fans, and these are huge. These are large fans that basically suck all the exhaust gas out of the boiler. So fans that are taller than you and me. Large rotating equipment. We have heat exchangers. Typically our heat exchangers use water and steam and air. In the hydrocarbon industry, they're going to be a little more risky. They're going to have the hydrocarbons. Alrighty. Now, what you're looking at here is the top of a boiler in Texas. That just to give you the idea that boilers are basically built within the building. They hang from the inside of the building. They're not supported by the bottom, and that's because as big as they are, when they heat up, they stretch. And we don't want them to run out of room, so we build all that design in, and they stretch from the top down. So, what else do we have? In the oil and gas and the chemical manufacturing space, we've got tanks, vessels, and piping. And they sound benign, but they're really important because that's where the process is. It lives within your tanks process and your vessels and your piping. And the way you manage all of that, just the ability to inspect the piping introduces a new challenge, and that is putting the plug ports back into the insulation ports, putting the plugs back in the insulation ports. So just the piping itself is critical, and it needs attention. They have reactors, catalysts, various forms of loss that aren't necessarily fire explosion can occur now when you have these processes going on that need continuous energy to sustain that reaction. Utilities, air, water. Huge, very critical in a processing plant. If you don't have adequate cooling water, you're going to tend to rob the fire protection system. And when that happens, the fire protection component may or may not be out of service, depending on how you connected to it. But definitely you're going to run your fire pump. A 3,000 GPM pump supplying a 5 or 10 gallon per minute cooling system is going to wear out your electric pump way faster than if you were just using it for fire training and fire service. So the water and utilities are crucial to ensure that you have your safety systems back when you need them. We call process units just a general name that defines a group of tanks and pumps and vessels and heat exchangers all in one section that make one part or one chemical for the process. Rotating equipment and heat exchangers. Again, like we mentioned, the heat exchangers here are carrying hydrocarbons, so they are a little bit more critical. We have in this space, again, it's heavy on the hydrocarbons, but it's still got power, it's still got rotating equipment, and there's still a lot of risk to be managed, especially in hydrocarbon facilities. T&D assets, what are we looking at? Pipelines, transmission lines, substations, switchgear buildings, transformers. Okay, a lot of the same stuff that we've already seen. But in this case, it's unmanned. It's probably out there. It gets maybe inspected once a week or once a month. You have potentially some SCADA or some sort of remote monitoring to give you an idea of if there's a component issue. But that information is sort of limited, and a lot of times you just get a general alarm and you have to go out and see what you see. Compressor stations would fall along this area of T&D, and again, if you work in a plant, you may not be aware of all these hazards and all this risk that carry with the product as we try and get it to market. So again, pipelines, compressors, transformers, a lot of the same stuff that we have, but in this case running by itself, so we may have to rely on external data sources to be able to get that information. Now let's shift gears a little bit. We've talked about what are the things that are in our sector, in the energy sector, and we've talked about some of the events that can happen to them and what property risks are. Let's talk about specifics that actually happen. And these, I kind of joke that it was in the energy industry, but it was really specifically in my experience. These are just a few of the things that I've experienced personally. We'll talk about simultaneously motoring 3 generators at a power plant that had 3 boilers, burning pistachio hulls to make steam for its steam turbines. We'll talk about a $25 million explosion at a cryogenic gas processing plant, and we'll talk about cracking a 3 million gallon LNG tank in downtown Baltimore. All right, first one, motoring 3 generators. Okay, this one, the big lessons learned were that your DCS systems, your control systems that rely on UPS, especially if that UPS isn't configured just right, you might not realize that it's not working. And what we had here was the battery charger failed, and there was a low voltage sensor to tell us that, but it basically was downstream of the battery bank. So we wouldn't know that the charger failed until the batteries died, which happened. Now, as the batteries were dying, the voltage was slowly going down. Throughout the plant, the hold-in voltages for all the relays, coils, they weren't exactly the same. And so we had uncoordinated tripping. We had the boiler trip, so no steam going to the turbine, but the generator did not trip. We're still connected to the grid. Well, with no steam going to the turbine, the grid pretty quickly started motorizing that generator, spinning it backwards. Well, that will overheat the steam turbine because remember, there's no steam cooling it down. Believe it or not, steam is the coolant when it goes through that turbine. I've seen motorized generators actually burn the paint off of the casing of the steam turbine. This lasted for about 45 minutes, and the way they eventually got it disconnected from the grid, they went out to the switch yard where they had a whole new set of breakers and another set of batteries that were on its own charger. So it was separate, and they were able to disconnect from the grid and get the plant stopped. So that was a interesting lesson learned. Big things can happen out here. A cryogenic plant had a explosion and fire. Nobody got injured. I made a 40-minute video that we will present, put up there for y'all to look at. But what this boiled down to was really a failure of PSM. And, you know, we can look back at the lessons learned after it, but I mean, PSM would have prevented it all. So what happened? Well, they didn't put a drain plug in after they drained a cryogenic part of the system. And when they drained that cryogenic part and closed the drain valve, it was on ice. So they thought they had isolation, but they didn't. And when that ice melted out the next day, a vapor cloud formed, an ignition source was found, and the fireball took off, and the rest was history. But we did get $3 million to put into fire protection, and we improved the PSM program. We moved the PSM coordinator out from the chain of command of operations, and we moved the plant manager basically into night dispatch duty. We cracked a 3 million gallon LNG tank in downtown Baltimore. It was not a good thing, and basically it started from debris left over from construction, vibrating its way over to a outtake or release valve from the LNG tank, and the extraction valve, so to say. That debris blocked the clapper from falling down on the seat, and then left the LNG open to the rest of the process. We had a check valve and a isolation valve, and in between the check valve and the isolation valve was a 2-inch relief valve. Well, the liquid that was trapped between the isolation valve and the check valve started to overpressurize and boil. It opened the 2-inch relief valve, which then started filling the subdike area of the LNG tank. Operators put on bunker gear, SCBAs, they put trash can lids over their heads, tied rope around themselves, and they went in with steam lances to try and warm up that 2-inch relief valve that was spraying LNG on the outer tank, because it cracked the outer tank and the crack was growing. Warm air was starting to get inside the LNG tank in that interstitial space, but it was warming up the LNG, so the boil-off rate started to increase. Eventually, we were able to get that relief valve shut. Nobody got hurt. Fire department showed up and basically asked if we needed any help. We didn't, and they left. Nobody got hurt, no explosions, no fires, but very near disaster in downtown Baltimore. All right, now we've talked about what property risks are. We've talked about what energy equipment is, and now just to summarize it all up, the factors that can influence risk are, primarily where you are, what you're doing, and how you're doing it, right? So wind is more of a problem in the Gulf area. Earthquakes are more of a problem in California. Here in the middle of the country, we get hail and ice. So, we've all got our medicine to, so to speak, to deal with. But the age of the facility can have an impact, an older one versus a new one. And don't always think that a new one's better. If you get a brand new facility with people who are just learning how to operate and all learning a new SCADA system or all learning a new control system versus the 20-year-old plant that's always done the same thing, it's never been overloaded, and the people that are working there have years of experience. We know that there's a couple oil leaks. We know that the brakes just got changed. We're ready to deal with the problems we know about because we've been running it for a long time. When you get a brand new plant, it may not be risk-free as we all wish that it would be. And then finally, what you're doing at that facility, actually blending things if you're doing something that's hazardous versus doing something that's pretty innocuous. Those will all impact or influence risk. So hopefully you've all learned what property-specific risks in the energy sector are, and you're ready to move forward. We're going to learn in the next video how to identify those risks, and that will get us closer to being able to read a risk engineering report. Thank you.